as soon as we start learning about new formulas, we're going to start seeing, and especially with the next one we're going to do as well with resistance, we're going to start to see some of these actual variables that are in the equations. So the current intensity equation has I is equal to Q over delta T, and then the potential difference equation has V is equal to E over Q. So we're starting to see some similarities, right? What one does these two have? Do these two equations have in common? Q. They have Q in common, okay? In the next formula that we're going to learn about, probably next class, and I'm just writing it out now, don't worry about it, but I'm just writing it out now to actually, show you, is that the resistance of a circuit or a resistor is equal to, the relationship between I, which is current intensity, and potential difference. The formula sets itself up as being the potential difference is actually also equal to the relationship between the current intensity and the resistance in a resistor in a circuit. So if you look at this, we see that Q repeats in two of them, okay? I repeats in two of them, and V repeats in two of them. So here's the deal. You can probably guess that you're going to get some math problems or some situational problems here that are going to involve more than one formula, where you might have to solve for something first, then input that value into the second equation. Okay? An example here would be that if I told you that, my iPhone has a current intensity of a particular number, and it also uses a particular voltage and consumes a certain, or uses a particular voltage over, an hour's time. What is the actual energy that's being consumed by my iPhone? Well, you could figure that out by using this equation, step 1, and this equation, step 2. So to give you an example, okay, to work through an example like that, because that's a lot of talk, and you're probably just like, whoa, what? If I were to say that Miss Lupel's iPhone has, a current of 20 amps, and it uses a voltage of, 120 volts over a period of 2 hours. Okay, if I gave you these values and I said, how much energy is this iPhone using in this amount of time? Okay, if that's what I was looking for. And of course, this would all be typed out in a paragraph, so you would have to actually take that information out. So I've typed out the actual word problem here, and we've written down all of our variables, okay? Because this is how you approach a problem like this, okay? This is how you actually look at this, and you're like, what can I do here? So I'm going to erase all these guys, get them out of the way, and I'm going to move this over. So when I'm actually approaching this, I know that I've got some variables here, and my suggestion is you start highlighting the things you have. And then you look at the formulas you have access to, and you see what can be used to solve what. Okay, so first things first, I've got 20 amps, I've got 120 volts, and I've got 2 hours. And it's asking me about energy. Okay, this is the guy that it's actually asking me to solve for. So if I look at my formulas, which I will always have access to, I need to see that one formula is this, and the other formula is this. So what of these variables here, of these 6 variables, which one am I actually trying to solve for? Which one? Energy, right? Ultimately, I need to get to this guy here, right? This is the one that I want to solve for. Can I just look at this formula and solve for it? No, why not? I can't right now because I'm missing 2 of my 3 variables. I don't have this guy and I don't have this guy. Okay, so I can't do that. But I know that I can actually solve this guy using another formula. All right? I can use my current intensity formula because at the end of the day, I have my current intensity and I have my time, right? So, if I look at this, first things first, do I have to make, so step 1 here in solving this is, do I have any conversions to make? So step by step, this is always how you should approach any combination problem. And you'll know if something is a combination problem if it's worth more than 2 or 3 marks. If it is worth 4 or 5 marks or more, then you have multiple equations that you're going to have to use. Okay? So I would make this probably like a 5-mark question. 1 mark for the conversion that you have to make. What conversion has to be made here? Hours needs to go to what? Seconds. So first things first, hours to seconds. So you've got 2 hours, and you want to convert that to how many seconds are in an hour? First of all, how many minutes are in an hour? 60 minutes. And then, so your hours cancel out. And then how many minutes are in, or how many seconds are you in a minute? 60. So minutes cancel out. And you're left with 2 times 3,600, which is 7,200 seconds, I believe. Okay, so that's my time conversion. 7,200 seconds. Can you just multiply the 2 hours by 3,600 seconds? Yep, you could do that. Okay, you don't have to do this step by step. I'm just showing you how you actually would. Okay, so I now have my time. Then what's number 2? Solve for the missing variable in the equation that has that variable that I need to solve for. If I look back at my first equation here, okay, I had current intensity and I have time to give me Q, which I will then be able to input into my final equation to get that ever important final answer. Okay? So in this case, do I have to rearrange that equation? The equation as such is I is equal to Q over delta T. What am I solving for? I'm solving for Q, so delta T needs to be multiplied by both sides, right? And that leaves me with Q is equal to I times delta T. Do I have my current intensity? What is it? 20 amps. You must include the units. You do not include your units the whole way through, you will lose part marks uselessly. Okay? What is my time? 7,200 seconds. So if I multiply those out, what am I left with? So this gives me 14,400. What's the unit for charge?
It's 144 144,000.
Ooh, 144,000. Whoops, that makes more sense. Whatever. There we go. C. Okay, coulombs. Now, I have my Q, so I'm going to input this value into, okay, this second equation. So part 3 of this, input missing variable into final equation and solve for unknown. Well, let's do that. My final equation, V is equal to E over Q. Do I need to rearrange this? Sure do. Going to get rid of Q on the bottom. E will be equal to potential difference times Q. Do I have my potential difference? What is it? 120 volts times 144,000 coulombs gives me what?
1,728,000.
Gives me 1,728,000. Wow, that is a big number. Joules. Now, I don't have to leave it like this. I can put it, this is totally acceptable, but I can also put it in scientific notation, which would basically, using your little waves that you love, mean going from here, where my decimal would be, 1. So that's 10 to the 1. 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, 10 to the 6, 10 to the 7. So that's the same thing as saying 1.728 times 10 to the 7 joules is my final answer. You could also convert that to kilojoules. We'll get to that later though. If you look at this actual step-by-step process, this is not a hard problem, but where some of you will undoubtedly get lost is you'll have a hard time decoding what you've been given and what you're trying to find. Okay? Have a look and write down all your variables. This is why we always start this problem by writing down what we've been given. Then you look at the actual equations that you have access to and see what works. See what can get you to that final equation. Now, getting to the final equation means you need to know what the symbols are for the stuff you're looking for. You need to know that energy is E. You need to know that potential difference is V. You need to know that charge is Q. Things like this. Okay? Because yes, it'll be written down underneath the formulas that you get, but if you don't actually know what any of that means, then this is useless to you. All right? So this is going to take a little bit of work on your part.